Hello, my dear friends. Welcome to my YouTube channel. Myself, Professor Prakash Auti, Senior Lecturer in Physics, Jain Polytechnic, Kuranjunar. Today, here we are going to learn Part 6, Error in Measurement from Chapter 1, that is Units and Measurement. So, in physics, we study various physical quantities. So, measurement, it is an important part of physics. So, while measuring certain physical quantities, there are difference between the actual value and the measured value. For example, if we have to find out length of a book, or we have to find out length of a table, and it comes to be 7.20 centimeter. This is actual value of length of table. And while measuring, this value comes suppose 7.19 centimeter. So there is difference between the actual value and the measured value. So this difference, it is simply called as error in measurement. Remember, error, it is not a mistake, it is a fault in measurement. So we can define error in measurement simply as fault in measurement, which may occur even in the most careful observation. Or we can say that an error, it is the difference between the actual value of a quantity and the value which is obtained by measurement. So we have to study the various causes of error. Why error occur in measurement? So there are various causes of error. The first reason, it is the instrument limitations. If the instrument itself is faulty, then the measurement, it becomes error. Error occurs in the measurement. Second type of or second cause of error, it is human limitations, which may occur because of carelessness, sense of hearing, sense of touch, sense of sight. Human limitations means the limitations of the observer, which is performing the experiment, which is taking the measurement. Because of its limitations, certain type of error occurs there. Third cause is defective setting of apparatus. If apparatus setting is not proper, then there will be error in measurement. If all the things are proper, even if there are changes in temperature, humidity, that is there are changes in the experimental condition or environmental condition, then because of this also error occurs in the measurement. So depending upon the various causes of error, we have three types of error. The first one, it is called as instrumental error, which is also called as constant error. The second one is systematic error, and the third one, it is called as random error. Let us study one by one all the three types of error. The first one is called as instrumental error or constant error. As the name indicates, instrumental error. So such type of error occurs because of use of faulty measuring instrument. If the instrument which we are using for the measurement itself is faulty, then such type of error occurs in the measurement. And if we use the same measuring instrument next time, same error follows there, and that's why such type of error, these are called as constant error. So we can define instrumental error as the error caused due to the use of faulty measuring instrument. Same measurement follows there, so we can say that these errors are also called as constant error. Same error follows because of the use of same faulty instrument. For example, if a meter scale which is not calibrated properly, then it will introduce instrumental or constant error. And to eliminate such type of error, we have to take the same measurement with different instrument. We can have example of this instrumental error as shown in figure here. This is called as zero error, because this is the needle of this instrument, it is not at zero position. So depending upon the position, we have two types of zero error: positive zero error and negative zero error. Positive zero error is subtracted from the actual reading, while negative zero error is added in the actual reading. Second type of error, it is called as systematic error, and such type of error are caused due to defective setting or adjustment of the instrument. Also it is caused due to human limitations. If the setting of apparatus is not proper, if the person or the observer which is performing the experiment, it is not taking measurement with great care, then such type of error occurs here. For example, when the pointer of a measuring instrument is not correctly pivoted, then systematic error occurs there. And if we have to eliminate such type of error, then we have to detect their cause and rules governing them. For example, as shown in figure, actual value of the measurement is 4.8 centimeter. But depending upon the position of the observer, how he looks, then there might be 4.7, 4.9 centimeter reading. So such type of error occurs because of the position of the observer, or you can say that because of the defective setting of apparatus or because of human limitations, and such type of error, hence it is called as systematic error. Third type of error, it is called as random error. Even if you take great care, certain types of error occurs in the measurements which are because of the changes in experimental conditions. So these are called as random errors. So these are caused even after using properly calibrated instruments or in spite of taking great care. So these types of error are due to changes in experimental or environmental conditions. So while performing experiments, there might be changes in temperature, humidity, etc., which cannot be controlled easily. So such type of error will occur there, and hence these are called as random errors. So we have to minimize such type of errors. Remember that errors cannot be eliminated completely, but we have to minimize such errors. So there is certain procedure to minimize such errors here. The first important one is take a large magnitude of the quantity which is to be measured. Use instruments having least count as small as possible. We know that the instrument, the measurement which gives the smallest least count, it is more accurate. So use instruments having least count as small as possible. Third one, take large number of readings and calculate the mean or the average value. Verify the readings from one instrument by using other instrument. Do not take the same reading with the same instrument. So take the same measurement with different instruments, and hence the errors can be minimized here. Now we can find out the analysis of the error, that is we have to find out the estimation of error. How much error is there in the measurement, that we have to calculate. For example, suppose you measure the oscillation period of a pendulum with a stopwatch 5 times. So 5 measurements are taken for the same measurements. So trial number 1, 2, 3, 4, 5 are given, and the measure values are given here. From all these measure value, the first step is to find out the mean value. Mean value or the average value of all the 5 readings gives the most probable value for time period. So find out the mean value or average value. In this example, it is 3.6. Second step, to find out absolute error. Absolute error, it is simply the difference between mean value and each individual value. We take only the magnitude, not sign. So all absolute error should be positive. The difference, it is written in mod. So absolute error, it is the difference between mean value and each individual value. So all from 5 different readings, 5 measured readings, we have found out 5 absolute errors. Now third step is to find out mean of all these absolute errors. The arithmetic mean of all the absolute errors is called as the mean absolute error. So in this example, it is 0.1. Fourth step is to find out relative error. Now we have 2 averages. From the 5 measurements, we have the mean reading, and from 5 absolute errors, we have average absolute error. Now take the ratio of these two averages. So relative error is the ratio of the mean absolute error to the mean value. So in this example, the relative error comes to be 0.028. And lastly, we have to find out percentage error. Percentage error, it is simply relative error multiplied by 100. So in our example, we have percentage error 2.8%. Remember, the reading with less percentage error is more accurate. In certain case, reporting of result is done by certain scientists or engineers. We can write in our example the period of oscillation has to be 3.6 plus minus 0.1 second. In this case, the first part 3.6, it is the average value of the reading, and the second part 0.1, it is average absolute error. Now let us have certain problem based on error. In the first example, we have given 3 readings and we have to find out finally percentage error. So first step here, to find out average length. So add all the 3 readings divided by 3, you get average length as 11.12 centimeter. Second step, find out all absolute errors. Absolute error, so for finding out absolute error, take difference of each reading and the average length and take it in its mod. So positive readings are taken. So absolute errors are found out here. From all absolute errors, find out average absolute error. Third, we have to find out relative error by using formula. average absolute error upon average reading, and then we can find out percentage error using formula relative error into 100. So final value becomes 0.0625%. In the second problem, we have given the mass of an object as 64.22 plus minus 0.01 kilogram, and we have to find out percentage error in the measurement. So remember, in such type of problem, the first part given here, it is 64.22, it is average reading. The second part, it is 0.01, it is average absolute error. So you can directly find out percentage error using formula average absolute error upon average reading multiplied by 100. So in this case, we write 0.01 upon 64.22 into 100. So percentage error becomes 0.016%. Third problem again is same, but it is given in different fashion. Length of an object measured by vernier caliper is given, it is 2.33 centimeter. So it is average value. The least count of vernier caliper is given 0.01 centimeter. So it is average absolute error. So to find out percentage error, we can use the same formula. Percentage error is equal to average absolute error upon average reading into 100. So it is 0.01 upon 2.33 multiplied by 100. So it becomes 0.429%. The fourth problem, we have to find out the more accurate measurement. So two measurements are given. So for two measurements, find out percentage error using the same formula average absolute error upon average reading into 100. So for first measurement, percentage error is 0.086%. For second measurement, percentage error calculated, it is 0.059%. And we know that the measurement with less percentage error is more accurate. Hence, the second measurement 2.55 plus minus 0.0015 millimeter is more accurate measurement. With this, let us have certain MCQs related with error in measurement. So first one, error can be minimized by. So you have seen that error, to minimize error, certain procedures are followed. The first important one is take large magnitude of quantity to be measured, take large number of readings, use the instrument with smallest least count. So error can be minimized by all of these procedures. So option D is the correct option here. Faulty instrument carries dash dash in measurement. So as the name indicates, faulty instrument, if the instrument itself faulty, then error occurs in the measurement and it is called as instrumental error. Remember, instrumental error, it is also called as constant error. Error is dash dash in a given measurement. Remember, error is not mistake in a measurement, it is the uncertainty in the measurement. The difference between the reading and the mean reading. So it is simply the absolute error. The ratio of average absolute error to mean reading is called as, we know that the ratio of two averages, it is called as relative error. So option D is correct one. Same person may get different readings because of human limitations. This comes under. So we have seen that the error which is caused because of human limitations, it is called as systematic error. The difference between the true value and measure value is known as. We have seen by definition of error, error is the difference between the true value and measured value. So the answer is error. The error due to change in experimental conditions is called as. We know that the errors which are occur because of experimental conditions, these are called as random errors which cannot be controlled easily. The error caused due to defective setting in the measuring instrument. By definition, the error caused because of defective setting in the measuring instrument, it is called as systematic error. Which type of error cannot be controlled? So we have seen earlier the error which is caused because of the experimental conditions, changes in temperature, humidity, etc. These are called as random errors and these are not controlled easily. Now in 11th MCQ, 5 readings are given. We have to find out average of all these 5 readings. So average reading can be found out by adding all these 5 readings divided by 5. So average reading in this case, it comes 0.6262 centimeter. That is option C. 12th, we have given measurement relative error is given, we have to find out percentage error. So percentage error can be found out using formula relative error multiplied by 100. So in this problem it comes 0.475%. So option C. 13. Mass of an object given in the fashion 3.75 plus minus 0.02 gram. We have to find out percentage error in the measurement. So whenever such type of measurement is given, remember that the first part 3.75 here, it is the average value. The second part 0.02, it is average absolute error. So we can find out percentage error using formula average absolute error upon average reading into 100. So in this problem it comes 0.53%. So option D is correct option here. Now in the 14th problem we have given 4 observations, and from these 4 observations we have to find out which one is the more accurate reading. So for each observation we have to find out percentage error, and the measurement with less percentage error will be more accurate. So let us find out percentage error in all these 4 measurements. So to find out percentage error we use formula percentage error is equal to average absolute error upon average reading into 100. So first observation percentage error comes 0.085%. Second percentage error comes 0.0136%. For third observation we have percentage error 2.22%, whereas fourth observation it has 5% percentage error. So among all these percentage error, the measurement with least percentage error is more accurate, and hence option B 22 plus minus 0.003 millimeter, this reading is more accurate reading. Thank you very much. If you like my video, you can like and subscribe my YouTube channel. Thank you very much.